Hi, this is Mr. Ward, and I'm doing a key for the Do Now for today, week 16, day 3. So you have the situation here where you've got 3 $1 bills, 2 $5 bills, and a $20 bill in your pocket. You're going to choose 2 bills without looking. All right, so we're going to find the probability. So for 36, what is the probability of getting a 5 and then a 1? Well, this is a compound probability, and we're not replacing in this case. Oh, no, we are replacing, actually. We're replacing. What we pull out, we're going to put it back in. So first thing we need to do is figure out how many possible outcomes there are. This is called the sample space. So there are 3 plus 2 plus 1 bills in your pockets. So the denominator is 3 plus 2 plus 1, which boils down to 6. So there's 6 possible outcomes in your pocket there. Okay, and then we're going to be doing 2 things. So first, we want to know the probability of a $5 bill. So there's 2 $5 bills. And then we also need to figure out, since we are replacing, the denominator still becomes 6. We need to figure out the probability of getting a $1 bill. So since we are replacing, the denominator stays the same. So what's the probability of getting a $1 bill? It's 3 possible out of 6 because there's 3 $1 bills. Now, since it's a compound probability and we have 2 events happening, we are going to multiply those 2 probabilities. So 2 out of 6 times 3 out of 6 is going to equal 6 out of 36. Okay, and you could have cross-reduced that ahead of time, or you can reduce it now, and you get 1 out of 6. There's a 1/6 probability if we pull a 5 and then pulling a 5 and then pulling a 1 without replacing it. Okay. Now for 37, we want to pull a $1 bill and then a $20 bill, but we're not replacing it. So first find the first event, which is a $1 bill. So it's still out of 6 bills in your pocket, and there are 3 $1 bills, so 3 out of 6. Now let's find the probability of the second event, which is dependent on the first event because we haven't replaced anything. In the first case, the events were independent of each other because we replaced. So we're pulling a $20 bill. The denominator has now changed because we didn't put a bill back in, so we now have 1 less. $20 bill, there's only 1 in our pocket, so there's only 1 possible outcome we want there. And since it's a compound probability, we are multiplying those probabilities. 3/6 times 1/5 is going to be 3 out of 30. Okay, and we can put an equal sign in there. We can, of course, reduce that to be 1 out of 10. So the probability of getting a $1 bill and then a 20 without replacing is 1/10. Okay, now here we have the classic spinner, and in this spinner, the color purple is supposed to be represented, but it is unfortunately weirdly colored. It's the color purple kind of comes out as bluish, but that's supposed to be purple. These are supposed to be green, and that's white. So I'm grabbing a few questions from this set. We're going to hit the spinner, and what is the probability of getting an even number? Okay, so first thing, we need to know the total possible outcomes. There are 1, 2, 3, 4, 5, 6. All of these are even the same size, so there are 6 possible outcomes. And how many of them are even? Well, 2 is even, 4 is even, and 6 is even. All the rest are odd. There are 1, 2, 3 possible even exact options, so the answer is 3/6 or 1/2 probability. What's the probability of getting something that's not white? Well, you could do it. You could either work out that there are 5 possibilities that are not white, or you could say there's 1 possibility that is white, and you could subtract that from 1. Either way is going to get you out of 6 possible outcomes. There are 5 possible outcomes that are not white. You could have also done it, like I said, 1 minus the 1 possible outcome that is white, and then you would still end up with 5/6. Okay, so now we're going to see what is the probability of getting an 8. I don't see any 8s on there. So the probability out of 6 possible outcomes, there are 0 possible outcomes that is an 8. This is an impossible probability. So the probability is 0. I hope that's